All right, what do you say we combine some properties of parallelograms in algebra? It's my favorite part, combining algebra with geometry. All right, let's see. We got a couple of diagrams here, a couple of figures. And the one over here to the left, where we're trying to solve for x and y. We want to find the variable. We want to find the value of each variable in the given parallelogram. So do we want to do the x's or y's first? Which one? Well, let's do the x's. This comes first in the alphabet. All right, so I've got this angle here, and it's defined as equal to 4x. And this angle here, I see as angle is defined as equal to 2x plus minus 6. Now, the properties of parallelograms that'll help me solve this is that these two are consecutive angles. They're not opposite each other. And in consecutive angles, this would be the opposite angle here, these two. This would be opposite to this would be opposite to that. And so since they are consecutive angles, they are supplementary. In other words, they equal, the two of them together, added together, equal 180. So we can set this up as 4x plus 2x minus 6 equals 180. And then solve for x. So let's combine the like terms. So that 4x and 2x is 6x. 6x minus 6 equals 180. And let's add 6 to both sides. Isolate that. Begin to isolate the x. So x is equal to 186. And then we divide both sides by 6. 6 going to 18 3 times. Then we're going to 6 1 time. And so x equals 31. Now, what about the y's? Well, the y's, I got this side here is equal to y plus 8, and this one is equal to 5y. And again, one of the properties of parallelograms is the opposite sides are congruent, so they equal each other. So I would set this up such as this: 5y equals y plus 8. They're going to equal each other. Now let's subtract 1y from both sides, and that's going to leave me with 4y equals 8. Divide by 4 both sides, and so y is going to equal 2. Using properties of parallelograms and algebra. Now, another property of parallelograms has to do with diagonals. And if we draw diagonals from the opposite vertices, then those diagonals are going to bisect each other. This is one of the diagonal properties of parallelograms. There's another one we're not dealing with in this, that each diagonal separates the parallelograms into two congruent triangles. But right now we're just dealing with the first one, Theorem 6.7. If a quadrilateral is a parallelogram, then its diagonals bisect each other. And so if they bisect each other at this point here, then this segment is going to equal this segment, and this segment is going to equal this segment, bisecting, cutting them in half. Now, if that's the case, then these two segments, because they're on the same diagonal, are going to equal each other. And we can solve here for z. And I would set this up as 3z minus 4 equals z plus 5. All right, so let's subtract the z from both sides. Let's see, I'll do it like this. We're going to subtract z from both sides, and we're going to add 4 to both sides. And when we do, we got 2z equals 9. 4 plus 5 is equal to 9. Divide by 2 both sides, and then z is going to equal 9 over 2. Or if I put that into a decimal or mixed number, it's going to equal 4.5. And so there we use one of the diagonal properties of parallelograms and algebra, my favorite part.